Hi, I'm Stevie C and the place to be, and it's bloody freezing in the office right now. In this video, I'm going to be making another LED bulb, this time with tendrils just like my neon bulb here. And yes, I know it's called a lamp. Lamps glow and bulbs grow, except mine seem to do both. I wanted a mix of cold and warm white, but I'm running a bit low on warm white LEDs. So instead I'll be using a mix of cold white, warm white, and these kinda yellow ones. Look up your chimney. The Tendril-Stem things will be made from lengths of this 600 volt rated solid core wire. I'll leave the order codes for Rapid Electronics parts in the video description text box. I'll be using this heat shrink sleeving to shroud the electrical connections, which are referenced to the mains, away from prying fingers. And I'll be situating the whole project in one of these reused compact fluorescent lamp bases. We have the incoming live and neutral supply here. This bayonet cap isn't polarised unlike an Edison screw lamp, but for the purposes of the schematic, I'm drawing live and neutral on our 240 volt AC supply. So I'll be using this 100 nanofarad dropper capacitor to limit the current. It has a 1 megohm discharge resistor across it. This prevents me getting a shock from the pins after unplugging the lamp. I also have a 330 ohm inrush limit resistor. This will also act as a last resort fuse should everything else go wrong. I'm using one of these single package full wave bridge rectifiers to convert AC to DC, part number W08M. And then finally I have an electrolytic capacitor for smoothing, rated 2.2 microfarads. So again, I'm thinking of doing about 40 LEDs, but this might change. I'm not sure how many stems I'll get in the base of the lamp. I'll just see as the project goes along. think this is the last LED. Depending on how I edit this, you'll see me cutting the lengths of wire I need for the LEDs. But obviously I forgot I'm not using a PCB. So instead of just the LEDs, actually I've got a neon here. So instead of the LEDs just going down onto a PCB, the wire actually needed to go from the LED down and back up again, which I forgot about. So I'll have to make do for the moment. So what I've done here is created a set of very elaborate fairy lights, essentially. So I'm going to go ahead and twist them all together now to make the tendril stems. So again, depending on how I edit this, you might have seen me grabbing one of the LEDs to twist the tendril stems and actually snap the connection off and have to resolder it. So I was trying as far as possible to twist the wires, but this hurts your fingers after a while. So I'm going to go ahead and test this in the Cliff quick test before I pot it into the lamp base. So, as ever, will it go kablamo or will it be amazing? Let's see. So now that that's the glue set, it's time to plug it in and let you see how much power it draws. So yeah, 0.6, 0.7 watts. Doesn't even register in the milliamps. So there you have it. my LED tendril bulb. We should install it into the hard hat, shouldn't we? Un momento, por favor. So there you have it. My LED tendril bulb taking its rightful place in my non-health and safety compliant hard hat. As usual, I had a couple of problems. I just started cutting lengths of wire willy-nilly, not thinking about how I was going to connect the LEDs to each other. If I'd been using the PCB, it wouldn't have been a problem. But I think it's actually turned out okay the way it is, to be honest. It is just an excuse to make another one, isn't it? Maybe one with colour changing LEDs. Or maybe all cold white. So, as usual, if you like this video, please click like. If you're not already subscribed, please do so. Leave comments about this project, or if you've got suggestions for future projects, leave them down below. And until next time, thanks for watching.